A smartphone manufacturer is interested in constructing a 90% confidence interval for the proportion of smartphones that break before the warranty expires. 86 of the 1681 randomly selected smartphones broke before the warranty expired. We're going to round all answers to 4 decimal places where possible. So there's some keywords in here that tells me what I'm going to do. I want to make a confidence interval for proportions. When we're dealing with proportions, we're really looking at the binomial distribution because we're looking at success versus not success. In this case, I'm going to define success as the smartphones break before expiration. So our value of P is going to be 86 out of 1681, which means our Q, I do 1 minus P, that gives me the Q is 1595 over 1681. So there's our P and there's our Q. Now, in order to use the normal distribution to estimate and create our confidence interval, we need to be able to make sure that our N times P is greater than 5 and our N times Q is greater than 5. Our N is the 1681. That's our sample size. So when I take P times 1681, I'm going to get 86, which is definitely greater than 5. When I take 1595 over 1681 and multiply it by 1681, that's definitely going to be over 5. So these check out. That means I can use Z critical to find the error. Now my point estimate is going to be 86 over 1681. That's what we're going to use to create our confidence interval. Now, we need to create a 90% confidence interval, which means our point estimate is going to go in the middle. I got to find my error so that when I add or subtract my error, that's going to give me my 90% confidence. So what we need to do is we need to find this value and this value. So in order to do that, we need to find our error so that we can add and subtract it to our point estimate. So our error formula is going to be our Z critical. And remember, we are able to use Z critical because we're using the normal distribution to estimate this binomial distribution because our sample size is big enough. And then we're going to take the square root of our, let me make this a little bit bigger. Then we're going to take the square root of our P, which is 86 over 1681, times our Q, which is 1595 over 1681, and divide that all by 1681. When you put that on the calculator, make sure that all of that is under the square root. Don't leave the 1681 out. That needs to be under the square root as well. Okay, so the last thing we need to do to find our error is we need to figure out what our Z critical is. So our Z critical tells us how many standard deviations away I am from the point estimate. So if I use inverse norm, I can figure that out. So if you notice, I have 5% of my area under the curve lies to the left of this point right here. So I can figure out what that Z is by doing inverse norm. So I'm going to put in 0.05 for my percentile, my area to the left. Then I'm going to put in my standard deviation 0 or my mean and my standard deviation 0 and 1 because we're using the standard normal curve for this. And what's going to happen is I'm going to get the value is negative 1.645 if I round to 3 places, which typically we do for this value. Okay, so my inverse norm, this value right here on the left is negative 1.645. So I know that I'm 1.645 standard deviations away from the center. Now, I don't really care about the negative because that's going to come into play when I add and subtract. What I'm really looking at is the distance from the center. So my Z critical is going to be 1.645. I'm going to multiply it by the square root that I just set up. Okay, when I put that all in on my calculator, I'm going to get that my error is 0.0088398298. Now keep all of these digits, because if you round on each intermediate step, then it's going to throw your answer off at the end. Wait till the very last step to round, which is why I left these values as fractions rather than put them in decimal form. I didn't want to round. I want to keep all of my digits right to the end. Okay, so this is my error. So my confidence interval is going to be whatever I get when I take my center, my point estimate, which is 86.1681, and I'm going to subtract 0.00. Let me just, instead of writing it all out, let me just put in E so that I save some room. I'm going to subtract my E, which is that all of those digits, 0.0088398298. That's going to be my lower limit. That's going to be this value right here. And then when I add the error, I'm going to get 86 over 1681. I'm going to add my error, and that's going to be my upper limit, which is going to be this value right here. Okay, for my lower limit, when I subtract my error, I'm going to get 0.0423 because the direction says to round to 4 places. When I add my error, remember to keep all your digits, we're going to end up getting 0.05 and then a whole bunch of 9s. So what's that going to do is that's going to force us to actually round it up to 0.06 because of all those 9s. So this is my confidence interval. So that means this value right here is 0.0423. And my upper limit is 0.06. Now there is a way to do this on the calculator. I'm going to show you how to do that. Let me pull up my calculator. Want to check your answer? You would go to the Stat button and you would arrow over to Tests. Now, because we were using proportions for our confidence interval and we were estimating using the normal distribution, I would come down and I would find this option right here on option A. It says one sample proportion Z interval. So I'm going to use that, and then we put in our values. Our number of successes was 86. Our sample size was 1681, and our confidence level was 90%, which means I would put it in as a decimal as 0.9. And I come down here and I hit calculate, and it gives me my confidence interval. I got a confidence interval of 0.04232 and 0.06. And it also gives us our point estimate here. We kept it as a fraction so that we didn't round, and we tried to be as accurate as possible. But if you take 86 divided by 1681, that is this proportion right here as a decimal. For part B, it says if many groups of 1681 randomly selected smartphones are selected, and then a different confidence interval would be produced for each group. About 90% of these confidence intervals will contain the true population proportion of all smartphones that break before the warranty expires. And about 10%, because it's going to be the complement of 90%, about 10% will not contain the true population proportion.